Okay, so first, I hate all the waffling. I apologize. I was supposed to test Wednesday, then I changed it because of the juniors and the PSAT. Then I said we're going to test tomorrow. But then over the weekend, I had all these band people absent, and I see this blood drive. Well, these tests are, for some of you, going hard enough. But the idea of you being lightheaded while you take my test, that's not good. Or absent. So the test is Wednesday. Test is Wednesday. If that's the same day as an AP, whatever, sorry, it is what it is. That's fine. Test is Wednesday. Be ready, and test is Wednesday. All right. The next thing. Jeez, it's stinking. So, yes, or just this last period, I taught like the wind, taught up to the bell, and the bell rang, and everybody left really quiet. It's kind of weird. And they all were looking at each other like this. And at the end, 3 of them came up to me and said, "Did you forget the problem set?" And the answer was yes, I did. And so they tried to get out, and they did successfully. They got out. I never hear it at all. Don't be the person that says anything. So they left. I did not give them problem sets, so I guess their homework will be this sprouts. That said, then, this homework, I was planning on doing a homework today and a homework tomorrow, but I guess this is it. It's due, and it's not even due Wednesday, because you have a test. It's due Thursday. One step for 4 days, I should lose my AP teaching credentials. Drummed out of the which is actually pretty common. I will have a test review to hand out tomorrow, but that's optional. So this homework is due Thursday. Okay?
Is it optional for extra credit?
No, I don't really do extra credit.
Do you like
I don't. Extra credit is it doesn't feel very.
If we make like a whole flow chart, like
How about 3 points?
I would
Because they teach
I think okay. And I would like some decorations. I would like the Greek alphabet, for example.
I'll do that for you.
But I can only put up so many alphabets. I don't know.
I'll do that for you.
For really? That would be cool. I will do extra credit once in a while, but test for you thing.
You said the dancing thing was extra credit.
That will be extra credit, yes.
How many credits on 2 months?
Enough to make it to be something you have to really consider. It's so much that you really have to say, yeah, I got that. There will be a chance to earn extra credit for dancing during a test. All right. So the lesson, here we go. Here we go. Recall back to when you learned areas, way back in set 58, 9, 60-ish region. It is pretty easy, although I got to say some of you did one of these badly on a recent homework. It was this region, and I saw one integral. That's amazing. Even more amazing was that you got the right answer magically, although your work was total nonsense. It's always amazing. Math magic. Yeah, you would definitely have to do too if you're no calculator. If you had a calculator and you could throw absolute value, cool. But if you said that was one integral without a calculator, which you did, and you got the right answer, nope, no way, not happening. Okay, so that's okay. I'll get you. But I will say this. In terms of areas, there are some times when one of the variables is just better than the other. In this case, for example, I would like x and not like y because in x there's only one integral, whereas in y there would be 2, although I guess I could do the product geometrically with a rectangle. setup-wise, x would be easier, okay? In terms of this equation, y equals 1 minus cosine of x. That is a function of x, because for any one x, there is exactly one y. But it's not a function of y, because for any one y, there are actually multiple, and I'm talking infinitely many x's. And so I would never use y in a case like that, because it would have to be two equations. In our cosine's case, I would have to do a lot of shifting around to get the second equation. It would be a mess, okay? Furthermore, or along the same lines, consider this cube. Again, this is a function of x, because for any one x, there's only one y, but it is most definitely not a function of y. If I were to write this equation in y terms, I would have to do at least 1, 2, 3 branches, and that would really stink. And that would just be knowing generally. Then I would actually have to solve the cube. Also, not a picnic. So, the point is, sometimes you just got to use one variable or the other. Well, that then means volumes are going to be different. If you are going around the y-axis, but you want to use x, that's not a disk anymore. That's something totally different. That's the point of today's lesson. What do you get when it's not a disk or a washer? Check out this case. Say you had y equals e to the x, the y-axis, and y equal e squared. Y equal e squared is not the e curve, it's a constant. Y equals a constant. E squared would be about 9-ish, so it would be up here. Yeah, here's y equals e squared. Yes. So the region is this. You follow? If I revolve that about the y-axis, then I would get that kind of shape. Really? All right. Now, old school ways, we would say if it goes around the y-axis, we would use a y-slice, which means we would get what? Washer or disk? Disk. That's a solid disk. And so we would say, all right, the volume of that is the sum of many cylinders pi r squared h's. In this case, the radius is the curve in y terms. So, natural log of y. The height is super thin or super small, and that's dy. And the limits of integration are from what to what? 1 to e squared. Okay, that's fine. That went pretty well, I gotta say. But what if I said, all right, now integrate that without a calculator? Okay, this is a good time to say not everything can be integrated. Not everything has an antiderivative. If, for example, I say integrate that, you say nope, cannot be integrated. There is nothing that yields that for a derivative. There isn't. Okay, so not everything has an antiderivative. In that case, if it's a definite integral, you do a numerical approximation some way. If it's an indefinite integral, you say not possible and call it good. Now, if then this had to be done without a calculator, this would be a case where I just wouldn't even know how to approach it. And so you say, no, there's got to be a better way. Well, let's try a better way. If instead that same region was found using x, then consider first and foremost how the rectangles would be different. If I used x, then the rectangles, approximating rectangles, might look like this. Now that first rectangle revolved would be a solid cylinder inside, but the next rectangle would have a big hole in it, and the next one would have a big hole in it, and so on. Oops, you get the idea. Now that's using a finite number of rectangles. But if you took these more and more slices, more rectangles, then instead of being that wide, it's not supposed to go to the order, by the way, it would be only that wide. And in fact, it would be barely any thickness at all. In fact, so thin, they would almost be like a piece of paper. It would almost be like that. And lots of them within it, like an onion. Okay, it'd be like tiny thin layers of onions skin like that. You know what I'm saying? Now our goal is to find the volume of that. Well, we find the volume by summing all those. Summing those cylindrical shells. They're like cylinders, but they're really just shells of cylinders, so they're so empty. Almost all space, really. Well, you do that by, instead of thinking of it like a cylinder, you think of it like a rectangular prism. If you unwrap it, then it starts to just be, oh, what's the volume of this rectangular prism? Well, let's go with this dimension here. This thickness, this paper, and I'm talking paper thin, like that thick. How thick is it? It's dx. What about, so we obviously need the volume. It's going to be the sum of many length times width times heights. All these rectangular prisms are all just length times width times heights. Okay? The width, or whatever you want to call it, is dx. What's this? What is it? Yeah, it comes from the circumference of this. When I unwrap it, this came from unwrapping the paper, so that's the circumference. 2 pi r. And this height is what it is. Okay? Now let's get into the nitty-gritty here, the details. Look at a couple of these here. When x was, maybe a half, when I drew the slice here, then the radius was a half. And when I drew another slice at 3/4, then the radius of the cylinder was 3/4. So in general then, when x is 1/2, the radius was 1/2. When x is 3/4, the radius is 3/4. So it seems like the radius of all those cylinders is always just x. Yeah? You see? Okay, now look at the red here. The heights of all these cylinders are these red segments. That's a vertical distance, so let's go upper minus lower. What's the upper point of? The upper point is always this point. So it's e squared. The lower point is varying, so it's the curve. The curve in x terms or y terms? X terms. So e squared minus the curve in x terms is dx. So if I say the volume is the sum of many length times width times heights, then it's 2 pi x for the width. The height is e squared minus e to x. And the length, or whatever the other third dimension you want to call is dx. From where to where? 0 to 2. Yeah, 0 to 2. Why 2? Yeah, this limit of integration is where y equals e to the x meets or equals e squared. And that's obviously when x equals. Yeah? Okay. That's the idea of a cylindrical shell. It's not so much a washer or a circle type of approach as an unwrapped rectangle approach. The 2 pi kind of comes about as the circumference, all right? So, that's the idea. Would you consider them? Let's try another one. Say I looked at the curve, which I'm not going to give myself enough room for. Give yourself room on the right, because we're going to revolve it to the y-axis. 1 minus cosine x. What does it look like? Has a range of 1 to 2 or 0 to 2? 0 to 2. And starts at a high or a low? A min or a max? Because it's negative cosine, it starts at a min. And by the time it hits 0 to 2 pi, it will have covered one period. Okay, now that is revolved around the x-axis. So if I reflect it and connect it, then I would get, oh, the y-axis, excuse me, revolving around the y-axis. I misspoke. Around the y-axis. Then I get this kind of bun cake kind of thing, yeah? What's the period? Isn't the period 2 pi? What's negative cosine? Do I have it right? Negative cosine is this, right? Okay, shift it up 1. Do I have this wrong?
Yeah, you do have that.
Okay. Okay. So it looks like that, yeah? And right away, I say, okay, so let's actually, this is one of the most common areas. I hear people saying this, well, should I use shells or washers? They ask me, should I use shells or washers? That's not the question you should ever be asking. You never ask that question. You ask yourself, should I use X or Y? That's the question. What do I got to use, X or Y? And the shells or washers flows from that answer. Not, I feel like using shells. That's not the question. Okay? In this case, you say, man, I definitely don't want to use Y because that's not a function of Y. It would have to be written in 2 pieces in Y. Y is terrible. Y is not happening. No Y. So you're going to use X. Now, if I make a X rectangle or 2, and then say, all right, what happens if I have to use X and revolve it? What do I get? That's shell, okay? But I didn't choose to use shells. I chose to use X. All right, so if I sum all those rectangles, if I take one of those rectangles and unwrap it, then the length, width, and height. Well, the thickness of that is super thin dx. The width, what is the width? 2 pi, and in this case, the radius is always x. And the height, upper minus lower, is just the function, yeah? 1 minus cosine x. Wait. So the integrand then would be the sum of many volumes of those, length times width times heights. If I sum all those length times width times heights, then when you do shells, typically instead of pi out front, you'll do 2 pi out front. I don't want you to memorize that. You should understand that's 2 pi by virtue of the circumference. That's why it's there, not just because I know I write it. Okay? It's by virtue of the circumference being x, 1 minus cosine of x, dx, and the limits? 0 to 2. Okay? Yes?
How do you know to use X, not Y again?
Because if I used y, then I would have the curve on this side minus the curve on that side, and the thickness would be dy. Now, all right, the thickness is dy, that's fine. But if I want to do the curve in y terms, if I put this in y terms, I would subtract 1, divide by negative. So I'd have 1 minus y, arc cosine of that, and that would only generate this. That would only be this curve. If I wanted this curve, I would actually have to take this curve, reflect it, and shift it over there to get this curve. That ain't happen. It's just not happen. Okay. So it's because if I write this, it can be written as a single equation of x, but if I did it in y, it's got to be lots of equations of y, and that's that. Okay. Good question. All right. Try one on your own. Try that bad boy right there. The radius of calculator to evaluate the integral. I want you to focus on just the setup. Although, in this case, the integral won't be very bad. Get something like that for your setup. Okay. This is a good example of why x would be superior. If I had to write this problem in y terms, I would have to complete the square to separate it into two. Yes.
So is R always X?
No.
Is there an example on this page where it's not?
No.
And
Yes. Okay, I will, just for the sake of argument, it's right to look for trends, but it's wrong to oversimplify a problem, okay? If I had the axis of revolution here, at x equal -1, then in this case, when I did a sliver at x equal 1, the radius is actually not 1, it's 1 plus 1, it's 2. The radius is 2. So, no. It could be a y value. So, again, you're right to look for trends, but hold off there. If there was a place to write, just use this minus formula, man, I'd have it on this paper. It's conceptual. Okay. So, are we cool on this? Okay, consider then, by the way of preparing, consider if we did this a little different. This was meant to be around the, no, it's around the y-axis. Never mind, my bad, sorry. I lied to you. No, x-axis. X-axis, my bad, it's wrong, that's x-axis. Should be x-axis. Okay, so, say you have yield square root, which was shifted. How was it shifted? 2 to the right or the left? Right, okay, looks like that. The x and y axis, all right, so all right, I don't have the region enclosed yet. Now to cap the region, I have y equals 4. So here. So there's my region in the dotted area. Okay, it's not the area below the curve. It's, no, wait, it's around the x-axis. It's the area above the curve and above the axis. Now, this is going to be revolved around the y-axis. So would you measure out that distance and about the same distance on the other side, reflect it. And we're getting this solid of revolution, which would look like a glass to the side, but once you looked at the side, it would be fairly hollow, though it would have a thick tip. Okay, now I could use x, and it wouldn't be too bad, but if I use x, how many regions do I have? Area and volume behave the same way. So if you have two regions for area, then you'll have two integrals for volume. If you used x, wouldn't you have two different upper minus lower conditions? See what I'm saying? So let's just for the sake, and that wouldn't be terrible actually, but let's say we wanted to use y instead. Now if I used y, my slices go this way, because dy now is the height or thickness, and that's a small change up and down. Now that's actually nice because that's only one integral, always the same right and always the same left. It's always the curve on the right and the axis on the left. You follow? Now if I revolve one of these slices, then I get a thin shell and a thin shell. That's disappointed in myself. Tons of thin shells. Again, think onion skins within each other, super thin, paper thin. So that I can find the volume by unwrapping it. Now here I'm going to cut it and unwrap it this way. Now the paper is more like it's this way. So when I go to unwrap it, it would be along that way. Cool? All right, so what's this thickness? It's dy. What's this? Whatever you want to call it. Height, I suppose, whatever. It's this. Do you hear me? Do you understand what I'm saying with the? It's the circumference. Wait. And this is the height. The height is the distance between the two bases. Something like that. Oui? Okay. All right. Here's where here's where I get you. You're cruising along, everything's going swimmingly, and then I get you. The radius. What's the radius? Yes? This?
Yeah.
It comes from or is tantamount to this thickness here. And in terms of how infinitesimally small it is, it's a small change from here to there. That's a small change vertically. See what I mean? Oh, I see what you're saying. So the way this, okay, if it was this way, then when I unwrap it, this thickness, I mean, that's basically the thickness of the paper. That's what was right here. And so, yeah, that's small change left up and down in the curve. So, okay? I'm glad you asked. So, what's the radius? It's the curve in y terms. Is it the curve in y terms? Yes?
Yeah.
How do you say curve in y terms? How do you say something else? You should say something else. What do you say?
Something else.
Okay, let me say this. Do you agree that there is a cylinder at the stage where y equals 1? Okay, what's the radius? 1. Yeah, here's the radius, and the radius is 1. Here's a cylinder where y is 2. Well, what's the radius? It's 2. Okay? And so it's always the radius is exactly, and y is 1, the radius is 1. Y is 2, the radius is 2. So it's straight up equal to y. So at that point, you got to say, wait a second, the curve's got to be in there somewhere. And it is. It'll be there. Don't you worry. Okay? It'll come in the height. Now the height, this is the height. Now, wouldn't you also say that that is some point on the curve? For example, when x is, when y, for right here, when I said y is 1, when y is 1, it must be the case that x is 3? Yeah? Do you see?
Yes.
Okay. Well, at this point, at this cylinder where y is 1, the x is 3, because the only way I'm going to get a y of 1 out of that is 3. Well, then what's the height? The height is 3. And here, when y is 2, that would only be the case if inside was 4, so x must have been 6. This point where the radius and y were 2, it was the case that x is 6. Well, that means that this height is 6. So the height is always x. It's the distance, the horizontal distance going from the axis to the curve. So the height's always x. Now the problem, though, is that the variable of integration is y. So that can't stand. I need to change y and put it into x, or sorry, change x and put it into y terms, which is y squared plus 2. Okay, so the curve comes in next one. All right, so the volume is 2 pi, and length times width times height is y squared plus 2 dy from 2 to 4. 0 to 4, which is, it's, what am I looking at, y or x? Y, what's the lowest of the region? Y. 0, what's the highest of the region? So it's 4. Okay. Takes practice. Don't you worry. You're doing fine. Would you change this, however? Sometimes you can actually get volumes within themselves. That's not exactly what I want. So would you consider changing this to x equals y minus 2 quantity squared and y equals negative x plus 4 around the x-axis? I want you to do this on your own, but let's get the picture first. We'll deal with pre-calculus skills if you have errors in your graphing later. Right now I want to focus on the calculus. What does y minus 2 quantity squared look like?
Sideways.
It's a sideways parabola shifted.
Right. Also, right.
Okay, question for you. When you do this, how is it shifted? Do you try to memorize that? Or do you think it's conceptual?
Oh, it's a line value that's going to move, so it's.
Conceptually is much more error-free. Okay, what's the lowest a square can be?
0.
0. Okay, that is the bottom of the that's the vertex of the parabola. In every case, no matter how it's rotated or turned, the vertex is where the 0 happens. Got it?
Yeah.
Where does the 0 happen?
At 0.
When y is 2 and x comes out
So
0. It's got to be up. Okay. Don't memorize right, left. That will fail you. Okay. Conceptually, the vertex of the parabola happens when the square is 0. Okay. So we got a sideways parabola here. Boom. Negative x plus 4 there. Boom. Okay. I think you'll see that they also meet at, well, that you'll figure out. You're smart. Okay, that's going around the x-axis, this region here. Oh, that's not. Oh, yeah. Okay, that's beautiful. Point proven. Haha. If I used x, how many integrals? 2. But if I use y, how many integrals? 1. It's always the same right sitting left, so y is better. So use y. No, no. Oh, yeah. Yes, thank you. That's why that did not look right. How you doing, my friends? Okay. Whether you put this in your calculator is up to you. I just want to see if you can still lift it. Give me a second to finish it up. Yours are not so awesome, no. And you need to get yourself into a lot of
I get the right answer.
I didn't draw it, I don't know.
You just,
good.
just like that? Just takes random.
Man, I would call it random.
I mean, like, well, it's kind of random, like, where you.
No, it's placed right
So you just draw by the boundaries.
Okay, is your integrand something like 2 pi? What's the radius?
Oh, yeah.
Well, you can see why, darn it. The hard part is the heights. The heights are constantly varying, and if I looked at each of these segments and I said, what about right, what about left? The right side is constantly varying, and the left side is constantly varying. That makes it hard, but the right side is always a point on the line, yeah? And the left side's always a point on the parabola. So I just think of it in terms of that height is the distance between, or the difference between the line and the parabola, but it's got to be in y terms. So did you get something like 4 minus y minus y minus 2 squared? quantity. Is that what you got? Limits?
0 to 3.
0 to 3. Okay. Questions on that one? All right. Last warning to, sorry. Shells are very unforgiving. Washers and discs, you can be pretty bad at calculus and still get the right answer. And that's by virtue of the square. If for example, say you had a region on this side, and you, say you had a region on this side, and you revolved it around the x-axis. Now, technically, those x's are negative. Yeah? And yet, because you're going to square, it doesn't ever really cost you, because the negative is lost by or negated by the square. In the washers, you'll see there is no radius squared. It's 2 pi r h. There's no square there. And so if you fail to set up the integral to force these to be positive, these must be positive to get a positive volume. And if you fail to do that, then you're going to have to choose. It'll be that great deciding point. Should I just slap some absolute value on it and do it in a really crappy way and take the straight one off? Or should I go back and figure out why it's coming out negative? And the answer to that is always B. Go back and figure out why it's negative, because it's not supposed to be wrong. All right, so look at this as an example. Y equals x squared minus 2x. It is a parabola that is occurring below the x-axis, like that, yeah? If you revolve it around let's go around the x, though. Oh, no, I want around the y-axis, okay? If you revolve this around the y-axis, what would be the better variable choice, x or y? X, because it's a function of x, but if I put it in y terms, it would have to be a little plus or minus action going on, yeah? So x is superior, and because I'm using x and I revolve x, that yields a shell. Okay, I'll say it again. You don't choose shells, you don't choose washers, you choose the variable, and the method follows from there. Okay? So I get a cylindrical shell. Cool. If I unwrap it, it's a long rectangular prism of very thin thinness, whatever, and it's dx thin. Okay, circumference is the bottom edge, 2 pi r, and the height is beta. In this case, what's the radius? The radius is x, true that. The height, is it the function? Well, consider this. At x equal 1, what's the height? When x equals 1, y is negative 1. Now, if you sum a lot of cylinders with positive x's at negative heights, you will get a negative volume. There's no mistake. Okay? These are negative. That's bad. So you must do something about it. Now, you have one of two approaches. Give me one thing you could do. Now, don't overthink it. Just say if negative y, if the y's are negative, then I can make them positive just by saying the opposite of the curve. Okay? That's fine. It works just fine. In terms of where we're headed, though, you might also consider just generally always boiling it down to upper minus lower. If you always do upper minus lower, then you will always be positive. Period. Every time. Okay? Now, in this case, for these segments, what's the upper mark? 0. And the lower is the function x squared minus 2x. And so really it amounts to the same thing. Negative x squared minus plus 2x, or 0 minus x squared minus 2x. It's the same. But in terms of preparing for where you're headed, I think if you just get in the habit of upper minus lower, you will be better off later. I'll take either one. What I won't take is slap an absolute value on it and calling it. All right, so the integrand is 2 pi, the radius is x, the height made positive is negative x squared plus 2x, or 0. I'm going to model what I want to see, what I would like to see. 0 minus x squared minus 2x dx. And the limits? 0. Okay. Everything will turn out positive because the x's are positive in that region. I made the heights positive in that region. The volume will be positive. It would be good. Okay? Good? Okay, cool. Let's go to ye old set 85 extra practice, shall we? I didn't post the full notes on, I wanted there to be a discussion about the AP problems, but doggone it, everything's going so fast and I just can't get caught up, so what's to be done? Let's at the very least start a discussion, shall we? Did we talk about that one? Oh, cool.
We're on 3, I think.
3 or C?
3.
3, oh, cool. Right on. Okay. Boom. I did have the original key I had up there, didn't have the AP problems on there, but I changed it and I had them covered up, but I put my full key up now, so if you need help, it's all there now. All right, so I take it back then. Okay, so is it just Elizabeth and I that are cool on number 1A and B, or are we all good? 1 you had to use? IVT, and B you had to use? MVT. C, are we cool on there? Did you get the chain rule? Do you understand why 1 doesn't matter? Do you understand this thoroughly all the way, or do we need to talk about this a little deeper? Sure. Okay, let me explain this. Now, there's a shortcut, and you can probably get the answer without thinking this deeply. But I would like you to understand what the heck is going on. If you want W prime, I need to take the derivative of this, but wouldn't you first need to take the antiderivative? So this, here, consider this. Let capital F be the antiderivative of little f. You follow? Okay. If I then wanted Wx, then I would take the antiderivative capital F and evaluate it at the upper minus at the lower. Cool? If I wanted the derivative then, that's why the chain rule. When I take the derivative on this, I have to take the derivative of the outside. Now that's the derivative of the antiderivative, which is just the function with g in it. But then by chain rule, I'd have to take the derivative of the inside. When I take the derivative on this, I don't know what the antiderivative is, but I know that at 1 it would be a constant, and therefore the derivative is 0. This then means nothing, and students hate that. What about the 1? Doesn't it mean anything? Is the 1? The 1 means nothing. Let me explain visually why. This is often called an area accumulation function, all right? It accumulates area under G from 1 up to a point. And now the further x gets, the more area you would accumulate, right? But if I talk about the rate at which area is accumulated, then that means as I go from here to here, what's the rate of change in the area? Well, if I go from there to there, isn't it all just about how high the curve is and how the curve is changing at that point? That's what's going to affect the rate of change in the area. Where I started from, I don't care. I'm talking about how area is accumulating, changing, and whether I start at 1 or -2, I don't care. It's all about the height. And that's why we'll finish going over tomorrow. Have a nice day. nothing due, that sounds so long. But, tomorrow we can get all caught up. Aha. Have a nice day. If you have